Hello, let's discuss some basics of binary search in today's video. We have the range 1 to 100 and there is some random number which is 29. We have to guess the number in the least number of choices possible. So what is the first idea? We can just travel from all the numbers 1 to 100 and if it is the original number, return j because j is the number of choices we have taken. For example, if the number is 1 and if it is the original number, we will return 1 because it's the first choice we have taken. And if it is 2, we have already selected 1 and 2 now. So the total number of guesses are 2, so we return 2. So in this way, we can find the random number in O of n because the maximum number of choices we can take is O of 100. To optimize this, let's take some basic observation. So the numbers in the range are 1 to 100 and the random number is here 29. So all the numbers before it are less than the original number and 29 is the number itself and all the numbers greater than 30 are greater than original. So let's say we have some function which can compare the guessed number and the original number. So for example, if the original number is 29 and the number we guessed is 80, so if there is a function that says it is greater than 29 or less than 29, can we do anything better? For example, the guessed number is greater than original number, then are our choices still be any of the numbers which are greater than guessed? For example, the number we guessed is 80 and the original number is 29. So the function returned that the number we guessed is greater than the original number. So the choices in our next iterations are ever in one of the 81, 82 and so on. No, because the number we chose is greater than it. So any number which is greater than the present number are surely greater than the original number and our answer cannot be in the range. So similarly, if the guessed number is less than original, for example, the number we found is 9 and it is less than 29. So is our answer ever possible in the before part of this in the range of 1 to 8? No, because it is less than this and the number will be in the right side of 9 and surely the range 1 to 8 is not considered for our further iterations. So initially low is 1 and high is 100. So if the guessed number is greater than the original, the maximum number we can choose next is the number before this because the numbers greater than this are useless from now. So high is guessed minus 1. So the new range will be high is less than the present one. And similarly, if the guessed one is less than the original one, the number we choose next is low guessed plus 1 because the previous range is useless. So it is guessed plus 1. And the low is changed to guessed plus 1 because the least number that we can choose next is guessed plus 1. But why we are doing this? Let's say the original number is this and the number we guessed is x. So the original search space where we can search the numbers are 1 to 100. If the number we guessed now, which is x, if it is greater than original, there is no need to check the numbers which are greater than x because the number will surely be in the left half. So the new numbers we are going to search is from 1 to x minus 1. So similarly, if the number is less than original, there is no need to check the numbers in the left part because our answer will surely lie in the right part. So the new part will be x plus 100. So in this way, we are trying to remove some of the numbers without guessing them because one of the drawbacks in the linear search is we are going to check all the numbers from 1 to 100. But now in this way, we are able to reduce some numbers as our choices. Let's take other one. So if the choice is 1 to 100 and the number initially we are guessing is 20 in the first case. So based on this, the new choice will be 1 to x minus 1 or x plus 1 to 100. So if the number is 20, the new space is 1 to 19 or 21 to 100. Similarly, if the number is 40, the choice will be 1 to 39 or 41 to 100 based on the number is greater than original or less than original. So let's take that we don't know the initial number and we are taking the worst choice possible. So for example, the choice are 1 to 19 and 21 to 100. So if we are guessing 20, what are the least number of choices that we are going to ignore? So for example, if our number is 16 and the initial guess is 20, so no need to check in the right part and the new part will be 1 to 19. So in this way, the least number of choices we are going to ignore is 19 because if the number is 27, we are going to check in the all numbers from 21 to 100. So if we are going in this part, then we are just able to ignore all numbers from 1 to 19. and because the new range will be 21 to 100. So if the initial number we guessed is 20, the least number of choices we are able to ignore is 19. Similarly, if the guessed number is 40, the least number of numbers we are going to ignore is 39. And similarly, if the number is 50, the least number of choices we are able to ignore is 49. And similarly, if it is 80, the answer is 19. So if we observe this carefully, the number initially we are going to guess is better if it is 50. Because in the least case, we are able to ignore 49. So we are able to reduce search space by half. So similarly, if the number is 20 or 80, we are just ignoring 19 numbers, which is very far less than 49. So initially, if the number is 1 and the number is 100, the low is 1 and the high is 100. The number to choose best is 50 because it is able to reduce major numbers from our search space. So the original number is 29 and the range is 1 to 100 and the number we guessed is 50. So it is greater than the number. So we are going to the left of the search space and it will be 1 to 49. So it is 50 and the number is 29, which is somewhere here. So we are able to reduce the search space to 1 to 49. Similarly, in the next one, we are going to 26 to 49 and 26 to 36 and so on. So in this way, we are able to reduce major part of the search space. But the low number is 1 and the high is 50. But how to find the number which is beneficial, which is 50? If we observe this carefully, this is the mid number of the whole range. So it is low plus high whole by 2, which is 50. So initially the low is 1 and the high is 100 and the number is 29. So the low comma high represents the search space we are going to search. So initially the low is 1 and the high is 100. So the search space is low to high, which is 1 to 100. When our iterations will be stopped? When the number we are going to guess is the correct number. So in this way, if the number is only 1, it is our final answer. And then low is equal to high because we have only a number which is the choice. So we are going to loop until low is less than or equal to high. So if low crossed the high, it means that we searched all the numbers and we found the original number successfully. So the loop is still low less than or equal to high and we are finding the mid, which is the number we are guessing now. So it is low plus high by 2 from this. So it is low plus high by 2. And if the number is greater than the original number, we can ignore the right part and high will be mid minus 1. And similarly, if it is less than the original number, we can ignore the left one and low is equal to mid plus 1. Else, we found the number, we are printing the number of choices we have taken, and finally we are incrementing the choice. In this way, we are able to find the number in the least choices possible. Let's check what is the time complexity in the algorithmic way. So, for example, the initial search space is T of n. So the total number of numbers we are going to guess is n. Here n is 100. So in this way, if we are trying to guess a number now, the choice of the next range is n by 2 because we are ignoring half part if we choose 50. So T of n is equal to T of n by 2 plus 1 because we are able to ignore half the part based on the number it is greater than or less than original, and 1 because we are guessing the present number now. So it will be T of n by 2 plus 1. So similarly, if we apply same here, we will get T of n by 4 plus 2. And similarly and so on till T of n by 2 power k plus k. So as we discussed that we found the answer when there is a single number possible. We discussed that n is the number of choices we have, and finally when we are going to find the number, we have only number 1 possible. So we found the number when n by 2 power k is 1. So if we take log on both sides, we get that k is equal to log n. So in this way, with only log n iterations, we are able to guess the number. Where in the linear search, it was n iterations because it will be worst case when the number is 100 and we are starting to count from 1. So let's take other example of binary search. Similarly, we have given a sorted array and we have to find whether number 18 exists in our array or not. So similarly, the linear search just traverse all the indices and return when we found an answer. And now coming to binary search, let's discuss why we are able to apply binary search here. Because the given array is sorted, all the numbers which are before 18 are less than 18, and the number is equal to 18, and the numbers next to it are surely greater than 18 because the array is sorted. So in the similar way like here, we can ignore half space by whether checking the present number is less than 18 or greater than 18. So similarly, low is 0 and high is n minus 1 because initially we have to search in the given array which is 0 and n minus 1. And now we are similarly making the loop till low less than or equal to high, and index is equal to middle index. And if it is less than x, which is 18, for example, if the mid is this, index is this, and this is less than 18, so is there a way to check all these? No. So the low will be index plus 1, and now the new search space will be this to this. And similarly, if it is greater, high is equal to index minus 1. Else we found the number and we can print the choices and we can break the loop. So in this way, with help of binary search, we are able to reduce the time complexity from n to log n, which is very low. So hope you understand this. Drop a like and comment below. See you in the next video.